The warehouse application that we are tasked to work in needs to be updated. We want to provide the consumers of the business layer with a way to run their own code when an order has been initialized and when the order processing is completed. Let's jump into Visual Studio. In the program, I am going to introduce two methods that I want to be invoked when the order reaches two different states. When the order has completed its initialization, I'd like to send a message to the personnel working in the warehouse to prepare them to pack the order. After the entire order has completed its processing, I'd like to send a confirmation email. Both methods are simple. They run some arbitrary test code, and they don't return anything. They also do not have any parameters passed to them. This could be solved in many ways, but I know that the business layer is used by many different applications. So building this behavior into the order processor wouldn't be a great idea. Your preferred architecture may vary. In our case, we are going to achieve all of this without requiring anyone to subclass or further extend the existing implementation. The business layer in the application provides a class that handles processing of an order. It exposes a public method. This will internally call other methods. One of them initializes the order. We'd now like to produce a way to run code when the order has completed its initialization, as well as when the order process is completed. This will provide both flexibility and extensibility. Imagine if this processor executes in the background, providing a way to get a callback when an order reaches a certain state allows the consumer to act on that information. This could be to populate the UI with some information about which order was most recently processed. To allow for such a callback, we are going to introduce a delegate. This will allow anyone that uses this class to pass a reference to the method they want to invoke when the order reaches a certain state. Hence, we are delegating the implementation to someone else. The methods initialize and process will both try to invoke two corresponding delegates. In other words, they will try to invoke methods that we are simply pointing to but do not belong to this class. Remember the methods from the program file? The idea is that the delegate that we create matches those method signatures. When the order processor is created, we need to provide a pointer to those methods. This class can then invoke the delegate, which will run the methods we've pointed to. When you create a delegate, you use the delegate keyword. This tells the compiler that you are about to specify the required method signature. After the delegate keyword, you specify the return type. We're not going to return anything at this point. Therefore, we'll specify void. Now it's time to give this delegate a name. Let's call it order initialized. As with all your types, it's good to give them a descriptive and understandable name. We are not going to pass any parameters when we invoke this delegate. Therefore, the method signature of this delegate is completed. You then use the name of the delegate as you'd use any type. A delegate can be declared inside or outside of a class. And you can, of course, use it with the access modifiers such as public, protected, internal, or private. The delegate must be at least as accessible as the way you expose it. This means you cannot declare a private delegate and expose it through a public method. Let's now use this delegate that we have created. You can introduce a property of type orderInitialized called onOrderInitialized. Let's expose both a public getter and a public setter. This property could now point to any method that corresponds with the method signature that we defined when declaring the delegate. The method you point to does not have to use the same name as the delegate. It only needs to match the method signature. Both methods defined in the program would be viable options as they have matching signatures. Before we get to that part, let's look at how to use the delegate to invoke a referenced method inside this class. Since the property is a delegate, which ultimately is just a referenced method, could we use this as a normal method call? Certainly. As you can see, if we call onOrderInitialized at the end of the initialize method, this looks like a normal method invocation, because that's exactly what it is. The whole point of the delegate is to allow it to point to a method that lives somewhere else, and might not even be known when this portion of the code is compiled. An external library or application could be setting this up when they consume this business layer. Without doing anything else, let's head over to the program and make sure that we create an order, the order processor, and then call the process method. What do you think will happen at this point? We haven't set onOrderInitialized to anything, so what will this method call do? You will get a null reference exception. If you think about it, it makes sense. The property hasn't been set to a value, hence the method reference is null, and therefore you get the null reference exception. As with any reference types, you can guard against this using an if statement to check if the property is null before you invoke the delegate. Instead of doing that, let's explore if there are any available methods on the delegate. There are a few methods and properties available, because when you use the delegate keyword, under the hoods, the compiler will use the type delegate or multicast delegate. There's one method that we want to use. That is the method invoke, which will allow you to invoke the delegate. You can also see begin invoke and end invoke, which are old ways of asynchronously invoke a method. Nowadays, you would use the task-based asynchronous pattern, which is thoroughly covered in my course about asynchronous programming. With that being said, you'll want to use the method invoke. Are you wondering why? Since this is a method call on a type, you could use the null conditional operator. This will make the code cleaner and easier to read. We'll talk more about avoiding null reference exceptions and other ways to approach this later in the course in the module Nullable Reference Types. If you rerun the application, there is no longer going to be a null reference exception. Surely that's a better experience. The order processor is now exposing a public property that allow you to reference a method that will be executed when the order has been initialized. We can go to the program and set the property to point to the method sendMessageToWarehouse. This can be done using normally property access or the object initializer. Keep in mind that you do not add the parenthesis because this is not a method call. You are now pointing to the method to delegate the work. Let's rerun the application with the debugger attached and see how this works. As you step into the method process and then into initialize, you can see that the property onOrderInitialized is referencing the method. When you step into the invocation, you should end up inside the sendMessageToWarehouse method. You've successfully delegated the work to a method that wasn't a part of the processor. An important note to make here is that since this delegate is a public property, and it's really just a pointer to a different method, anyone that has access to this property could invoke the method. This could be seen as one of the drawbacks of publicly exposed delegates. There's no rule as to who owns the invocation. You could simply invoke the delegate like any other method on the order processor instance from anywhere in the application. Let's add one more delegate. Create a delegate that returns void, called process completed. Because this is used like a normal type, you could add this as a parameter to the method process. I'm going to make it optional and set it to the default value of null. Then call this at the appropriate time. The second parameter to the method process now accepts a delegate, as opposed to exposing the delegate as a public property. This approach allows you to control that this delegate is only invoked from this class, which makes a lot of sense. We most certainly wouldn't want this delegate to be executed when there, in fact, hasn't been an order initialized. Exposing that delegate publicly would, however, allow anyone to invoke it. Going back to where the method process is being called, we can now pass a reference to a method. Just as before, simply write the method name that you want to reference. As you run the application, both delegates should be invoked, and you've successfully introduced a way for anyone that uses this class to run code in the processing chain without having to do any further extensions of this class. All they must do is pass a reference to a method. There's still a lot to learn about delegates. Next, we are going to explore how to return values and how to add parameters.